Okay, hello everyone. Somebody just shout to make sure you can hear me okay.
Oh, yeah. Yep.
Yep.
Thank you. Okay, so welcome back to another training session. You've got me again now, although from next week you'll have a guest lecturer, Simon Wellesley Miller, who has been on the HSMA program before and is a big part of the NHSR community. So he'll be doing a lot of the we're doing all of the R training because most of us in the team don't use R. So hopefully you saw my message earlier. Unfortunately, we've had to. Simon's got a clash that he can't get out of on the 14th. So we've shifted what would have been on the 14th to the 21st, the following week, which was a blank week. So apologies for that. If you can't make that one, don't worry, it will be recorded. Most of the fundamental stuff he will go over in the first session, and then go into some of the more advanced stuff in that second session. But he will post up some instructions as well. There's nothing. He's actually going to use RStudio Cloud, so you won't need to install anything. Although if you've got RStudio installed locally, which hopefully you have, because it's one of the things we told you to install at the start, then obviously that'll be useful if you're going to go and use R in earnest moving forward. But if you do, don't ask me anything about it because I don't like R. Or R doesn't like me. It's mutual, really. Okay, so what else was I going to say? Oh yes, so hopefully for those of you who took the assessment this morning, hopefully it wasn't too horrific. Please try not to worry about it. I know a few people were a bit concerned about, making silly mistakes and stuff like that. Don't worry, it's not there. That's why we don't formally mark it. It's just there for us to, see you've understood enough. We're not going to not take your project forward because you forgot to put, a bracket at the end of a command or something like that. That's not how it works. And usually there's a kind of clear division between most people who will be able to do we feel would be comfortable enough, and perhaps those that self-recognize they may be a little further off at this point. That's absolutely fine. There's no they're not compared, they're not marked, so and we may not even see it depends on your project pitch, but hopefully I did hear a few people that it was fun, which was good. So hopefully we made it as painless as possible, at least as painless as you can try to make an assessment anyway. So the other thing I was going to say, I can't say officially, so I'm just going to bear with me 1 second. Sorry, I'm just going to pause the recording. Good. Right. So that was the other thing I wanted to mention. And oh yes, and the other thing I just wanted to say. So obviously you're coming towards the end of the training phase now. You've got after this week, you've got the R training, which will be next week, and now the week after next. And then there's one more training session from me, which will be on the 28th, which is the Git training. That one I've left at the end. I was tempted to bring that forward to I would rather Git's a headache. It's not very pleasant, and I'd rather you didn't have to worry about it before you got in your project proposals. It's something that you can deal with after. So it's a very important thing, and we'll talk to you about why free and open source is important as part of that as well. And there's a nice light intro, but it can be a bit of a headache, Git. So yes, that one will be coming up. But Elliot's very kindly drawn up some surveys to send out to you, which we'll be sending out to you. I did suggest possibly the day before you do the Git training, but we will send that out at the end of phase one. Please provide us with feedback on your experience of the program. It all helps us to improve and identify where we can focus our attentions or make changes, etc., moving forward. So do look out for that towards the end of phase one. And also please don't forget, you've now got a month to put in your project proposals. You've been pretty much shown everything now. Obviously, we've got the reinforcement learning we'll show you this afternoon, which you might decide you want to explore a little bit, but this is a bit more exploratory. So it might be something you weave in if you're doing a maybe a sort of slightly more machine learning project, or even an agent-based simulation project, which we'll come on to. But it may not be the core focus because it's a bit more exploratory, this stuff. And you don't have to worry about the Git stuff or the R stuff because that's just some little side appetizers, if you like. So hopefully you've now, after this afternoon, you'll have seen all of the sort of key methods and hopefully starting to put together some ideas. So do refer back to that information that we posted earlier, about a month ago, about what you need to do for your project pitches and what we're looking for. Remember, short videos that basically outline what you're going to do and why we should care about it. So keep posting on the forum. If you've decided at this point you are not going to put in a proposal yourself, you want to join another project team, which I guess at least half of you have done, because we had about half took the assessment this morning. So if that's the case, then you may want to start contacting people now to identify whether there are projects you'd like to sort of help out with the pitch and then going into the project for phase 2. Are there any questions about any sort of general logistical stuff before we move on? Yes, Agal.
Hiya. I've got a question about continuing support. So I don't plan to put in a pitch, but I am planning to do a project. Mm-hmm. It's just the timing for the project with ending in December and stuff doesn't quite fit. Mm-hmm. So I have a project. We've already pitched it. We're getting the go-ahead hopefully very soon. But how much support will there be for people who didn't choose to do a pitch and still want some help in doing their own project on the side?
Okay, so formally we can't give any support from ourselves because we are going to be taking on 20 projects basically, up to 20. So there won't be any formal support. But what I would encourage you to do is to make use of the Slack community, because not only will that a lot of the issues you might be encountering will probably be similar to what other people are encountering on their projects, and so maybe able to give some advice. And some of the depending on what your project is, some of the wider Pencore team members might also be able to sort of informally help with some of that stuff as well. So it's always worth posting, and particularly, we've got the alumni on there. Quite a few of those are quite active still on there. So it's still worth kind of chucking. We've had people that have gone on to do other things from the previous cohorts who have posted questions on there and arranged to chat with people. So that would probably be your port of call, I think, for that.
Great, thank you.
No worries. Okay, in which case let's crack on. So you can probably guess what this particular session is going to be themed around. This is going to be a very different session. So this is a brand new session. We in HSMA 3 we introduced reinforcement learning. Mike did a fantastic 2.5-hour video, which I will link to if you want to go and watch it, because it's really good if you want to get into what's known as deep reinforcement learning, which I'll talk more about a bit later. But what we found is that it was a little bit too much, and people didn't really engage with it, so we took it away for HSMA 4. But I'm kind of the principles of reinforcement learning are actually quite important. It's quite an interesting avenue, and my background is in reinforcement learning. In my PhD, that was around agent-based simulation and reinforcement learning, and so we felt it was worth bringing it back. So we've brought it back in a rather lighter way. So there is absolutely no Python code today, no code of any kind, which I'm sure you'll be delighted with given the test this morning. And we're only going to basically introduce you to some of the main concepts, just to get you thinking a little bit about whether this is something of interest, and to get you thinking about whether there are potential ideas for some of your projects that could use these kinds of methods. And if there are, then there's a lot of work that Mike's been doing in particular that may be able to help you. So it's a bit of a lighter one today, and hopefully we can have a bit of fun. hopefully you've all nominated a spokesperson for your peer support group. If you haven't, I'd get on Slack now in your peer support group chat and nominate someone. They will speak on behalf of your group for the 3 games that we are going to play this afternoon, which, as you may have guessed, are all themed around this particular show.
And hours of anxiety of Apollo 13.
She's walking in the air, she's dancing in the sky, and everyone who sees her greets her as she flies. Treasure hunt.
Hello, and welcome to this week's treasure hunt.
Okay, so we are going to play a game 3 times in slightly different ways that is slightly inspired by the classic 80s TV series Treasure Hunt. This was the original Python assessment, was going to be themed around Treasure Hunt. I had all sorts of things around building classes of helicopter, and then I started getting into clues, and it got very complicated. So hence why I went with the Crystal Maze. But I did think this was a natural fit for what I'm going to be talking about this afternoon, which is reinforcement learning. So this is Dan Chalk's Treasure Hunt, which is, as I say, slightly inspired, although in many ways completely different, to the 80s TV series, but does still feature Annika Rice in a helicopter, which is the main thing. So you are presented with a grid of 5 by 5 cells, so 25 cells arranged in a 5 by 5 grid, each of which represents a location that contains treasure. Now, each location is denoted using a letter, which represents the column, so A, B, C, D, and E, and a number, which represents the row, so 1 to 5, and we give a letter number combination. So C3 would be the middle one, E1, this one up here, etc. So your task, working as an entire cohort, you're all going to be working together, is to guide Annika in her helicopter to various locations on the grid, and you're going to dig for treasure. And you need to find as much treasure as possible within the time limit. Now, each location contains treasure. So there are no locations that contain no treasure. And you can also assume there is sufficient treasure in any location such that you would never run out for the duration of this game. Okay. But the probability of digging up treasure on any turn will vary across the landscape. So some locations, the probability that you will dig up treasure on a given turn will be much higher, and in other locations it will be much lower. Now, what's going to happen is each peer support group is going to play in turn with their nominated volunteer spokesperson, who will speak on behalf of the group, and you will be able to, the spokesperson will be able to communicate with the group via the Slack channel, your own peer support group Slack channel, so you can talk about what you're going to do. Now, each group is going to get 20 turns, so you'll have a total of 200 turns as an entire cohort. Remember, you are working as an entire cohort, so although you'll be taking it in turns in your teams, you're all working together to try and get as much treasure as possible. Now, on each turn, whichever group that is in play can choose to do one of 2 things. You can either dig for treasure in your current location, which consumes 1 turn, or you can move to another location and then dig, and that consumes 2 turns, 1 turn to travel to the location and 1 turn to dig there. We'll assume for simplicity here that all locations are assumed to be reachable within 1 turn. So it doesn't matter where you go, it'll take you 1 turn to get there. Couple things to note there. If you move on turn 200, the very final turn, you will move, but you will not be able to dig, because so you will consume a turn and then for no reason, because you'll have run out of turns. The second thing to note, on the very first turn, so for whoever the first group is going to be, which we're going to randomly select, there is no travel cost. Basically, you can choose, the first group can choose where to start, and you don't consume a turn for that. Okay. So after you dig at a location, one of 2 things will happen. You'll either find 1 unit of treasure, or you will not find any treasure at all. Okay, so it's a simple binary outcome. Now, after each dig, you're going to be presented with an updated grid, which will recolor the cells that are based on the success rate that you as a cohort are having in each cell, i.e. it's the number of successful digs you've had, a dig that's resulted in treasure, divided by the total digs in that location. And at the start, the success rate for all cells is 0 because you haven't dug up anything. Okay, so it starts as white, and as the success rate goes up, you'll see it gradually goes through yellows, then orange, red, and then purple for the very highest success rates. But remember, this is just your own personal success rate that you've had. So a scale next to the grid will show the color scheme used here, and you'll also get an update of your current total treasure every time you dig up some treasure. Every time you take a turn, you can then choose whether you want to dig again in the same location. You might choose to stay there and dig again. Remember, you won't run out of treasure anywhere. So you can choose to stay if you like, or you can choose to move somewhere else. So you're always making a decision, do I stay and dig again, or do I move somewhere else? And if so, where do I go? Now, if you're on the final turn for your group, you can only dig. You can't move and dig. So be aware, if you're on the turn 20 or turn 40 or turn 60, etc., I'll only allow you to dig, because otherwise you'll consume a turn from the next group. Now, just for a bit of added competitiveness, I had a go. I got Elliot to have a go at playing this game last week. Now, Elliot was new to this game as well. I explained the rules in exactly the same way I've just explained them to you. He doesn't know where the treasure is, and he scored 54 units of treasure, which is actually a pretty good score. So I'm interested to see if you, as an HSMA 5 cohort, can beat Elliot's score. Let's see if you can beat Elliot on this particular game. Okay. Are there any questions about any of this?
Do we have the slides anywhere that we can look at?
Not yet, no.
Okay.
There's a very good reason that I haven't given you the slides yet, because it'll give things away. So let me, I'll rattle back through the principles. 5x5 grid. Each group will go in a particular order. So we will basically spin the wheel of names to decide the order. You will on your each turn, you get 20 turns in your group, and for each turn you simply decide, do I stay where I am and dig, which consumes 1 turn, or do I move to another location and then dig, which will automatically consume 2 turns. You're basically trying to get as much treasure as possible, and you need to keep an eye on the grid, which will recolor based on your own personal success rates, and that may help you make certain decisions. But the key thing is you need to beat the magic number of 54, because that's what Elliot scored. Okay. If anything's unclear as you play, feel free to, because we're going to play this live, you can shout out and say, if you want to check anything, if you're not sure what to do, just shout, and I can tell you. Okay, any other questions?
Yeah, can I ask a question? So the probability distribution is unknown to start with in the grid. Is just revealed by how you're digging and whether you found the treasure or not, and the colors as they change. Is that right?
That's right, yes. I'm not telling you
Okay.
what the distribution is at the moment, other than to say there are some locations that may be better than others. Any other questions? Okay. What I'm going to do, because I've got this on video optimize mode, so I'm going to stop sharing for a moment, and I will reshare and turn that off. Right, 2 seconds. Okay, right. So, first of all, we need to spin the. Oh no, actually, we don't. Sorry, we don't for this one because you are all working together. So we're not going to spin the wheel of names for this first particular thing. So I think, is it Acorn Archimedes that's our first group alphabetically? It is. So Acorn Archimedes, you are going to be first up. Let me just shrink this down here. So hopefully you've got a nominated spokesperson. Let's set the program running. And before you get too excited, you'll note the true treasure values here are in fact loaded in. So I haven't hard coded them. That would slightly give it away. So let me bring this up. Let me shrink that down and make this a bit bigger. Oh, actually, I'll need no. Let's keep that there. Okay, so Acorn Archimedes, do we have a nominated spokesperson for your group? Do we have anybody from Acorn Archimedes?
Can we go for move to C3 and dig?
C3. Okay, so you will you're going to start at C3, so you can go to C3 without any penalty because you get to choose as the first group which one you're going to start with. So C3. Let's see what happens. Okay, you found treasure. That's a good start. You got 1 unit of treasure. 53 to go to beat Elliot. Hello?
You frozen, Dan?
Oh, sorry.
Can you hear me now?
Yes, sorry, that was my internet. It's a bit shaky.
Okay.
My apologies. Can we go to B3 and dig, please?
B3. Okay, so remember, you can stay, you can choose to stay, or you can choose to move. So you're going to go to B3. So you'll consume 2 turns by doing this. B3, well done. Another unit of treasure. Good start.
Can we go to B4 and dig, please?
B4 and dig. Well, you went to B4, you dug, and there was nothing.
Ooh, can we go to C4 and dig, please?
C4. Nothing there, unfortunately, on that turn.
Okay. D4 and dig, please.
How do you say D4, sorry?
Yes, D for Delta.
Thank you. D4, yeah, well done. Got some more treasure. We've got some nice little purple blocks appearing there.
Okay, I think that's us done for Acorn Archimedes. We're on turn 10, aren't we?
No, you get 20 turns.
Oh yeah, 20. Sorry, reminders. D3.
D3. Well done. More treasure. This is looking good.
D2.
D2. Nothing at D2.
C2.
C2. No, you didn't find anything there.
B2.
B2. Nothing on that turn, unfortunately.
Ooh, can we go back to finally C3 and dig, please?
C3 and dig. Okay, so that will be your final one. Oh, hang on. That should have. Oh yeah. No. Sorry. Yes, you get 1 final turn. Because you're now on turn number 20, so you didn't get anything at C3 that time. But you can now. Well, the only thing you can now do is to dig again at C3 because this is your final turn number. So if we go to C3 again, see if you got anything. No, you didn't get anything that time, unfortunately. Okay, let me remind who's next up is Amiga 500. We've got the spokesperson for Amiga 500. So we're up to, what are we up to? I should have put the units of treasure for every 4. You're up to 4. There we go. I'll know that for next time. So you are currently at C3, Amiga. Do you want to stay or do you want to move?
We stay.
You stay?
Yeah,
okay.
Please.
C3. Oh, that was a good choice. Yeah, you found some treasure. Well done.
Can we dig there again?
Yep, of course. Yes, more treasure. Excellent.
Can I ask the question that was just asked in the chat? Does it have to be adjacent squares we move to, or can we just fly anywhere in the helicopter?
You can fly anywhere. You've got your helicopter and an excellent pilot.
Excellent. A1, please.
A1, right. Let's go out to the
Thank you.
border to see what happens. Oh, nothing there. That was a shame.
Can we dig there again?
Let's try again. Yeah, let's not give up. Unfortunately, still nothing though.
B1.
B1. Oh, yeah, you had a bit more success there.
Okay. C1. Please.
C1. Okay. No, didn't find anything on that one.
C1 again.
C1 again. No, nothing still.
Okay. And third time lucky, C1. So.
Is it C1?
Oh, yeah.
Yep, nothing still.
Okay. Sorry, just reading Slack.
Yeah, that's okay.
What? How many was that on there? 2, 3. C1 again. I'm interested.
C1. Yeah.
Yeah, please.
Oh yes, you did find treasure that time. Hold on.
Okay. C1 again.
C1 again. And you found treasure again. Okay, you're sticking with it.
Yeah. C2, please.
C2. Okay. Oh yes, well done. Got some treasure there.
What's that? 36. C2 again.
C2. Yes, more treasure.
D2.
D2. Nothing at D2 on this turn, unfortunately.
And then we'll dig there another 2 times for the last 2 goes.
So nothing the first time and still nothing the second time, unfortunately. Okay, well done though. You got a nice bit of treasure accumulated there. So next up we've got Amstrad CPC. You are currently at D2. Do you stay or do you go? We've got someone from Amstrad.
Hi, yeah, I'll talk for the team.
Okay,
I'm
great.
on Slack, but I've not got any messages come up from anyone.
Okay.
Okay.
You get to make executive decisions.
Okay. Where am I at the moment? Sorry.
So you're at D2 at the moment, and the
D2,
previous team
okay.
weren't having much luck there.
Okay, we'll go right down to the bottom, A5.
A5, yeah.
Dig, please.
Let's try that down there, shall we? No, didn't have any luck there, unfortunately.
Okay. If any of the team want to put on Slack where they want me to move to. Okay, we'll go along to B5.
B5,
and dig.
try that. No luck there, unfortunately.
And we'll dig again there.
Try again at B5. Still nothing there, unfortunately.
We'll go back to C3 and dig.
C3. You flew there. Unfortunately, nothing on that turn.
Not doing very well, am I? E5.
E5.
Please.
Okay, let's try E5. No, unfortunately, nothing yet.
And we'll dig again at E5.
E5, yeah. Let's stick with it, see what happens. Oh, no, still nothing.
C4.
C4. Okay, let's try C4.
Dig.
Aha! You found the treasure. Well done. Okay.
C3 next, please.
C3. No, didn't get anything at C3 that time.
E1, please.
Hooray! Yes, you got some treasure. We're up to 13 now.
Just watching my screen. Okay. B5 next, please.
B5. Okay. B5. No, nothing. Unfortunately.
Nothing. And have we got one more? A5, please.
Well, you've got two more, so you can.
Okay. A5.
Yeah. A5.
Please. And dig.
A5. No, you flew there. Nothing, unfortunately.
Okay, thank you.
Got a couple bits of treasure. Okay, so that was Amstrad. So Apple Macintosh, you're up next. You are currently at A5, and you've got 13 units of treasure. We need to take Elliot down here.
Hello, everybody. Yeah, I'm on Slack, guys. Okay, I've been told B3.
B3. Okay, let's see what B3 brings us. B3 brought us nothing. Damn you, B3.
Oh. I'm going to stick with B3. Let's go again.
Stick with B3. Let's stick with it. Yeah, see what we get. Ah, you found treasure. Worth sticking with it.
And once more for luck.
Once more. Ah, yes, you found more treasure.
Ooh. B3 again, please.
B3 again. And more treasure. This is looking good.
Oh. Go on, let's keep going.
Let's keep going for it. Okay. And more. Okay, we're up to 17 units of treasure now.
And more.
And again. And again, you found more treasure.
Yeah, I like a good thing. B3.
B3 again. Ah, nothing that time. It had
let's. So I'm just looking at Slack, see if anything comes up. I'm thinking that I'm going to go along to D3.
Let's try D3. Okay. Nothing there, unfortunately.
Okay, up to E1.
E1. Again, nothing.
Oh. How about C2?
C2. Ah, nothing. It started so well.
Oh. Well, let's go back to it then. Let's go back to B3.
B3. Let's go to B3. Let's see what happens. Ah, yeah, you see, a lot changed again. 19 is a treasure now.
I like B3. Let's go B3 again.
We're going to stick with B3. Oh, didn't like you that time, unfortunately.
Oh, damn it. D4.
D4. No, nothing. So your final one, you'll have to stay with D4.
Yeah.
And still nothing, unfortunately. Okay, but we did accrue a bit extra treasure that time, so we're now up to 19 units of treasure. This is looking quite good so far. Okay, excellent. So it's now Atari 800. You are in D4 with 19 units of treasure. We've got a good thing going here so
far. Can we go with A1, please, Dan?
A1. Let's see what happens. Nothing there, unfortunately.
Let's try B3 again.
B3. Nothing still on that one.
E3.
E3. Okay. Yeah, you found treasure. Well
done. E3 again, please.
E3 again. Nothing that time, though.
E3 again.
Try it again. Oh yeah, bit more luck. Found a bit of treasure.
And again.
Nothing that time.
C4.
So did you say B4?
C4, sorry.
C4. Yep. No, nothing there.
Go for C2.
C2. Oh no, nothing there either, unfortunately.
Try B3 again.
Let's try B3. Ah, yes, you found some treasure.
And again.
Again. No, nothing that time.
And D3.
D3. No, nothing there, unfortunately.
Try D2.
D2. Okay, so this will be your last turn because you'll move and then dig.
Okay.
D2, nothing, unfortunately, there. Okay, so we had a bit of success there, but it sort of tailed off a little bit. So that was Atari 800. We've now got Atari ST is next up. You are at D2. We are halfway through. And what are we up to? We are up to 22 units of treasure. So we're a little bit behind where we need to be if we're going to beat Elliot.
Can we go to B3, please?
B3. Nothing at B3.
Can we dig again?
Let's try again. Yep, you found some treasure.
Keep digging.
Keep digging. Nothing that time.
One more time.
Right, once more. Ah, nothing that time either.
Okay, can we move to B1, please?
B1, okay. Oh, nothing.
One more time.
Still nothing.
Okay, can we go to A4?
A4. Okay, let's try A4. Nothing.
One more time.
Still nothing.
Okay, B5.
B5. Hooray, we found some treasure. Okay, we got treasure at B5.
Okay, let's dig there again.
Dig there again. Nothing that time, though.
One more time.
No, nothing. We don't have much luck.
Okay, let's go back to B3.
B3. Good old B3. No, nothing.
Let's
B3.
dig there however many times we've got left.
Okay, you want to B3. Oh, you found treasure that time. Excellent. Let's try it again. Ah, and more treasure. And last time, yes, you got more treasure. Okay, it was worth that final push. So we're now up to 27 units of treasure. So we're a little bit behind, but we can still make this hop. Okay, so that was Atari ST. BBC Micro, you are up next. You are in good old B3, which seems to be quite a popular location now. But do you want to stay or do you want to move?
Yeah, let's dig in B3 again.
Dig in B3? Nothing that time.
One more time.
Right, once more. Oh, nothing. Damn you, B3.
Yeah, it's not going to be good for me. Try D3.
D3, okay. Nothing at D3.
And again.
Still nothing.
Nothing's being suggested on Slack at all. Try E3.
E3? Nothing at E3.
Yeah, we're a bit unlucky then, aren't we? Yeah, do it again.
Do it again.
I'm getting some instructions now.
Oh, yep, you got some treasure.
So I can blame them if I get terrible results. I've been told to do it again.
Do it again. Okay, let's try it again. Yes, you got treasure again. Fantastic.
Let's do it one more time.
Sorry, just checking that updated. Okay, so try it once more. Oh, nothing that time.
Okay, let's move and try E1.
E1. Okay. Yeah, you got some treasure.
And we'll do it again.
And again, nothing that time.
Let's try. Is there any cells that people haven't gone to?
Yes, there are.
Wasn't paying attention enough. A2.
Try A2. You found treasure at A2. Well done.
Yeah, let's give that another go then.
Another go. Oh, nothing that time though.
I'm being told D4.
D4. Well done. Yep, you got some treasure.
And
so if you move now, you will have to. That will be your final turn, or you can choose to stay.
Shall we do? We're tell you what, we do 2 more in D4.
2 more D4. Okay, yeah, found treasure, but nothing the second time. But not a bad little move. You managed to get a bit of extra treasure there. Fantastic. Okay, thank you. So Commodore 64, you're up next. You've got you're in D4 and you've got 33 units of treasure. You need 21 to match Elliot, but really we want to beat him. So we can do this, team.
I can do it. Can we do D4?
D4.
Mm-hmm.
You can, and you found treasure. Well done.
Can we go again?
And again, nothing that time though.
Another time?
It's still nothing.
Do once more.
Once more. Oh, yeah, you found some treasure that time.
Okay, go for another one.
Another one, yep. Yes, and more treasure.
And again.
And again. And more. Okay, this is looking better.
Okay, go again.
And again. Oh, nothing that time. Spoke too soon.
A couple more, do 2 more.
2 more. Nothing that time. And oh yeah, you did the second time though. So you're now up to 38.
Okay. You get more goose the less you move, yeah?
You do, yes.
Okay, then we'll do a couple more times.
Couple more. Nothing that time and nothing the second time.
Go again.
Oh no, it's all turning. It's still nothing.
Another one?
Try it again. Oh no, what happened? This is all going so well.
I'll just go again.
But we're going to stick with it. D4, no, this is not, oh dear, it's turning on us.
It's going to be a whole run of wins soon. Once more.
Once more. Ah, yeah, okay, you're back in the winning streak, 39.
How many goes do you have left?
So you're on 156, so you got 5 goes, including this one.
Okay. Right, let's hit up B3.
B3. Okay, oh, nothing there.
Again.
And again. Yeah, you found some treasure that time.
Again.
And again. So that's, yes, you found more treasure. And then because this is your final go, you'll have to play B3 again. Yeah. And there was nothing that time. But well done. You managed to accumulate quite a bit. So we're up to 41 units of treasure now. We are getting hot on the heels of Elliot. And we've still got 40 turns left. Okay, come on, we can do this. We can absolutely do this. So it's turn for IBM PC. Can you get us closer to Elliot's score?
Hey, Dan, can I try A3, please?
A3, certainly. Nothing there, unfortunately.
Okay, try it again.
And again, still nothing.
Okay. Can I try, let's go to B3.
B3, good old B3. Oh, B3 is not our friend anymore. Look at it.
Okay, and try B3 once more.
B3 once more. Oh, yeah, we've got some payout this time.
And once more again.
And again. Okay, that's better.
And go again.
And again. Oh, nothing that time.
Okay, in that case, let's move to E4. Oh, sorry, E3.
E3.
Okay. Yeah.
Oh, nothing that time.
Once more.
And still nothing.
Let's try E4.
E4. Nothing.
Once more.
And again, nothing.
D1.
D1, nothing.
Okay, the 3s. Let's try C3.
C3. Oh, yeah, you found some treasure.
And well, forgot potentially 2 more. So just stay in there and twice more, dig twice more.
Stay at C3 twice more. Okay, let's fingers crossed. Oh, yeah, we got this on the first time and the second time. Okay, well done. So we are now up to 46 units of treasure, and we have 20 turns left to beat Elliot's 54 score. It is all down to our trusty ZX Spectrum, the rubber-keyed wonder. Can you pull this out? Can you get us the 9 points to beat Elliot? You
Hiya,
are currently
Dan.
at C3. Hello.
We're gonna go to B3 and
You're going to
use
go to B3.
all of our turns to dig there, please.
You're going to use all of your turns. Okay, this is a risky strategy, but I like it.
Yeah.
Okay, this is your final answer. Okay, all of them at B3. Let's see what happens. We've got treasure. This is very tense. Nothing that time. You've got more treasure, but nothing that time. More treasure. And again. Oh, this is edging so close to Elliot's score. Nothing that time. This is very tense. Yes, we've got more treasure. Come on. Nothing that time. Nothing that time. This is so close. 52 units of treasure. Come on, we can do this. Oh, nothing. 53 units of treasure. We're one off equaling Elliot. Nothing. 54. Okay, we have equaled Elliot. We just need one more unit of treasure and we have beaten him. And we've done it. Well done. 55 units of treasure. Let's see what happens. Nothing there. Nothing there. Do we get anything on our final turn? Yes, we did. So we've beat it by 2 points. Well done. Well done, cohort. You have accumulated 56 units of treasure. Excellent work. Okay, so now that was hopefully a bit of fun. But before we plow on, let me show you. So you've got 56 units. Now you explored that landscape and you were starting to build a picture of what the landscape might look like. There were definitely areas that you did not explore. So I'm now going to show you what the actual probability distribution looked like across the landscape. Okay. So actually, B3, your good friend B3, was all right. About 40% of the time it would pay out. What you all managed to avoid, it was the one that I was waiting for you to land on, was good old E2, which was by far the highest paying cell in the grid. 70% of the time you would have found. Now, I will say Elliot found E2 quite late, but did manage to find it. So when you weren't finding it, I was slightly concerned you weren't going to beat his score, but you did. That you managed to find something that was decent enough. But this little pattern down here, you can see some of these were absolutely atrocious. A4 and B4 in particular, very low levels of payout compared to some of the others. But actually, most of the payout was over to the right. And kind of around the middle-ish area. But particularly if you'd stumbled on this, or indeed E5, E was most definitely the best column by far to dig for treasure. You would have found some interesting stuff. So let's talk about how you approach this. What were you doing? So do people just want to sort of shout out well, let's hear from the first group actually, first of all. What were you doing? What was your strategy on this?
I think the strategy was just to gain as much data as possible. But retrospectively, I think you probably should have just done something like dig 5 times, move, dig 5 times, and stuff like that, rather than one each. But hindsight's 20/20.
Yes, absolutely. Absolutely. Well, of course, now you know, with hindsight, you just dig an E2, of course, which is now you know where they are. Any other strategies that people were adopting as it moved throughout the game?
To like use something you knew was okay and just keep commit to it.
Yeah, so you very much did that. You went in and found something that was probably good enough, did a little bit of looking around, but thought, well, this seems to be paying out enough that it's creeping the score up. And that was an interesting strategy. And I guess, so what was your thinking, ZX Spectrum, as you being sort of last op, you went very bold and said, let's just dig there. What was your thinking behind that?
We kind of thought moving was a waste of turns, so just stick somewhere that you know is okay and dig.
Okay, so that's interesting. So we've got the first group who are talking very much about we wanted to accumulate information. And then we've kind of got a middle group that was saying we've kind of found something that we think is good enough. Maybe we'll stick there, but we'll still explore a little bit. And then the final group is just saying we just need to get treasure now. We've got the kind of information. We're wasting time by moving around. Let's just play our hand based on the information we've got. And that's quite interesting, and that's exactly what I observed happening throughout that game. There were very different strategies that were accumulating from the first teams that were playing this through to the last team that was playing this. So let's talk a little bit about reinforcement learning. So reinforcement learning is basically a branch of AI in which we have an agent, and that agent takes actions within an environment, and it's doing so in order to try and maximize the amount of reward that it accumulates. Okay, now each action that our reinforcement learning agent takes results in either reward of some sort or a punishment, which often can be just the absence of reward, a bit like we've seen a moment ago, a waste of time essentially. So the agent essentially will take actions that are in part trial and error, but it's also maintaining a perception of the likely reward structure of the environment and trying to grow a better understanding of which things tend to lead to more reward and which things tend to lead to either less reward or punishment. So because of that, a reinforcement learning agent gradually learns to take actions that are more likely to lead to reward, and it gradually learns to avoid actions that either don't lead to reward or to some other negative punishment. And I've mentioned it before, but in the animal world, animals typically use reinforcement learning, particularly when they're foraging for food. So you remember my PhD was in modeling bumblebees, and we used agent-based simulation with reinforcement learning, because that's how a lot of animals forage. They learn where there tends to be food, their reward, they need to eat food to live, and so that becomes their motivation, and they tend to do things that will lead to more food. If we train a dog, for example, we might reward them with treats for good behavior. That's a form of reinforcement learning. If you're a cat owner like I am, they tend to train us to do things, particularly giving them treats. They may rub around our legs, or they won't relentlessly meow at us for a short period of time if we reward them in some way. In fact, cats are experts at reinforcement learning because they have trained us so well. Now, in the world of animal behavior, there's a very famous experiment. You've probably heard of it before, known as the Skinner box experiment, also sometimes referred to as operant conditional chamber. It was developed by B.F. Skinner, American psychologist, and very, very famous. You will have heard of a variant of this, I am sure, but basically in the experiment, an animal is placed in a box, and it learns to respond to some form of stimuli. It might be pulling levers. It depends on what the animal is, and it will learn to do the things that will give it food. Now, interestingly, the same principle was applied in 2015, and you may have heard about this news story, where they actually taught pigeons to recognize images of cancerous cells, and they did this by showing them images and rewarding them with a food pellet when they pecked the button correctly when it was a cancerous image. So what basically happened was they gradually learned to peck when they saw something that was actually a cancerous image. Yes, exactly like the machine learning algorithms that you've been learning about. Now, what was astonishing about this was they found that within a matter of hours, a single pigeon could do better than random. Okay, that's quite astonishing in itself. Within a month, a single pigeon's accuracy was around 80% at detecting cancer. And even more astonishing, they found if they showed the images to a flock of pigeons and they took the most popular answer, they got 99% accuracy. So 99% of the time, that's equivalent to human experts who have been trained in this. So clearly, the answer to all this is we need more pigeons, and that was quite astonishing. But it just goes to show you the power of reinforcement learning. They don't know they're pecking at things, but they're seeing something. They don't know that it's cancer that they're looking at, but they're seeing something they've learned because they're reinforcement learning agents. They have learnt when to peck, and they will be rewarded if they identify this thing. So the game you just played was a reinforcement learning problem. And in fact, it's a particular type of reinforcement learning problem known as a multi-armed bandit. Now, in a multi-armed bandit problem, we have an agent, and the agent is choosing between actions that may or may not lead to reward, and each action that it can choose from has an underlying reward probability. Okay, so much as you had the grid of cells, each of those cells had a probability ranging from the very bottom, sort of 2% chance you weren't going to, very unlikely you were going to get anything on any particular turn unless you really stuck with it. On average, you'd have got about 4 units of treasure in the whole game if you stayed there, compared to 70% success rate in the E2, which unfortunately none of you went to. Now, multi-armed bandit can be thought of as, think of someone walking into a casino and they're presented with a number of one-armed bandits, slot machines, okay? And they can choose whichever ones they want to play. And the player is trying to choose which machines to play such that they're trying to maximize their payout. In other words, their reward, okay? This is a common problem in reinforcement learning, and it's known as the multi-armed bandit problem. So in the treasure hunt game, your environment was a grid of cells representing different locations. Each of those locations are effectively one-armed bandits with different levels of probability that they will pay out on any particular pull of the bandit. And you played the game as the agent. You were making decisions to try and maximize the amount of reward, principally to try and beat Elliot's score, which you did. And each action that you took, either to dig or to move and dig, led to some form of reward, either 1 unit of treasure being accumulated, or you got a 0 reward, and that was your punishment, because you essentially wasted at least a turn, maybe even 2, if you had to move there. Now, the strategies that you were employing to try and accumulate your reward and make these decisions, whether they were conscious or unconscious, and in fact, sounds like quite a few of them were quite conscious, matched a fundamental dilemma in reinforcement learning, and it's known as the exploitation dilemma. So the exploitation dilemma is a common thing that you'll come across in reinforcement learning. When you've got an agent who is a reinforcement learning agent, essentially in the same way that you did when you played this game, you had 2 types of decision to make in terms of your strategy. You could either exploit, in other words, you took an action that, according to the information you had gathered so far, would lead to the highest reward. Or you can explore. You can deliberately take an action that either might seem suboptimal, or you don't know the outcome, it's an unknown, but which will help you gain more information about the environment, recognizing that you won't know everything at the start, and also that the perceptions you've got may well be wrong. Okay, so we saw that in the game that you played. The very first team was trying to gather information. It was exploring. Whereas by the time we got to the end of the game, the final team ZX Spectrum was just exploiting. Okay, there was no exploration whatsoever. It was just about, okay, we've gathered information, let's exploit based on what we have. And it turns out, that was, you could argue that there needed to be a bit more exploration because you didn't find the best patch. And perhaps you could have got more. So sometimes in the treasure hunt game, you exploited. In other words, you thought, well, that's a good one. B3 was a common one that you thought was pretty good, even though actually it turned out to be middling. And you decided, okay, B3's paid out, let's go to B3. But sometimes you thought, no, let's go somewhere else and try something. We heard, are there any we haven't been to yet? So balancing exploration and exploitation decisions in reinforcement learning can mean the difference between really good performance and really poor performance. And there are various algorithms that can be used to try and establish what that balance should be. But it's a very fundamental part of reinforcement learning. Do you kind of sacrifice your some potential reward now in order to gather more information, or do you just stick with how things are now and assume that's the best you can get? Okay, time's it. So just gone 2:30. So we will break until just before 10:02. We're gonna have a bit of an extended break. When we come back, we're going to play this game twice more, but slightly differently. So you're not going to play it in the same way you did before, not least because you know where all the patches are now, and you know where all the reward is. But you're going to play it slightly differently. I'm going to introduce you to some interesting concepts, and we're going to use some reinforcement learning agents, and you're going to play competitively against the other groups this time. Okay, so go and take a break, and I'll see you back just before 10:02. Okay, welcome back, everyone. So hopefully you had time to stretch your legs there. So as I say, we're now going to play the game again twice more, but this time it'll be very different, and you'll also be armed with some information. We will be using the same landscape, so you know where the good stuff is, but that may not help you quite as much as you think, because this time you're not going to be playing yourselves. You're going to be playing, each group is going to be playing against each other, and you're going to be playing via a very, very simple reinforcement learning agent. So let me bring up the slides. Okay, where are we? Right. So we're going to play again. This time it's going to be a bit differently for the second round. So as I say, this time each group is going to be playing against each other. So you're not all working as a cohort this time. You've already successfully beaten Elliot, even though you didn't find the best patch, which is quite impressive. And you won't be making choices yourself this time, okay? Instead, I've coded, and I do emphasize the word very here, a very, very simple reinforcement learning agent that will play on your behalf. So I'm explaining to you how the agent works, okay? So the agent basically maintains an estimate of the payout probability of each location in the grid, much as you were doing yourselves as human beings when you were playing a moment ago. And now at the start, these estimates are generated completely at random. So this below grid is just for illustrative purposes. It will generate some random numbers between 0 and 1, and those will be its initial estimates of how good things are. Now, on each turn, the agent will either exploit or it will explore. And whether the agent exploits or explores on each turn is determined using a simple probability. So if the agent exploits, then what it'll do is it will choose to dig or move to and dig at the location that it currently estimates to have the highest reward payout. If there's a tie, and you've got two locations with identical highest payout, estimated payouts, then it'll basically dig at the first location that it encounters with reading left to right, top to bottom. So in this case here, if these were the estimates, it's got two highest estimates of 0.99, this patch here and this patch here. So in this case, the very simple agent would just choose this one, because that's the first one it would encounter reading left to right, top to bottom. Because of the way it updates its estimates, you're not likely to get ties too often. Now, if the agent explores, then it will simply choose any location at random, regardless of the estimate it currently holds. So it might choose the best, but it might also just choose the worst or anything in between. It'll just pick one of them at random, and if it's already there, it'll stay there. If it's not, it'll move and dig at that location. After each dig, the agent will update its estimate exactly as we did before. So it will calculate the number of successful digs in that location divided by the total number of digs in that location. So in this example, the agent chose to go to this particular cell. If the agent dug there and they got treasure, and it's the first time they've dug there, that will now become a value of 1 because they've had a 1/1 success rate. Okay, so exactly the same as before. It's just this time they're going to start with assuming everything is randomly allocated, and then it'll explore or exploit. The agent is going to play by exactly the same rules as you did. It also has 200 turns, just as you did. Moving, other than the first move, will cost it an extra turn. And crucially, it does not know the real payouts of each location. There's no cheating. It doesn't know where the actual payouts are. Okay. So here's how we're going to play. I'm going to ask each group to play in turn. This time the order is going to be random to make it fairer, because you are playing competitively this time. Now, each group for this round only has to decide one thing, and that is how they want to set the probability that the agent exploits on any given turn. So you basically, each group just needs to give me a value between 0 and 1. A value of 1 would mean that the agent would never explore. It would just always go to the one it thinks is the best, because it would be 100% of the time it would be exploiting rather than exploring. And a value of 0 would mean it would always explore. So every turn it will just randomly pick a patch regardless of what it thinks is like. And obviously anything you've got everything then in between. So the agent will play the game on your group's behalf using the exploitation rate that you specify. And at the end of each game, we're going to find out how much treasure it accumulated. So each group should have a chat in their Slack group to decide which rate you're going to use. There's only one decision you've got to make for this round. That might change as you observe what the other groups are doing. So to be fair, we are going to randomly pick the order here, because obviously the first group may be at a disadvantage because they're going to have to go a little bit more blindly. Okay, so is everybody clear on this? So you've only got one decision to make in your group. It's basically the probability that on any given turn, the agent will exploit. In other words, will pick the best patch, what it thinks is the best patch, rather than just randomly exploring. Okay. So hopefully you've all got either the spokesperson or you've nominated a new one. Either is fine. I'm just going to, because this thing gets overloaded, I'm just going to close that down and reopen it. This will work. There we go. Okay. It is that one. Yes. Okay. So it'll be exactly the same as before, but it's going to play out really quickly, and you'll see the grid update, and you'll see what will happen. But first, we need to pick our initial group. So let's spin. I've already shuffled these. Let's spin the wheel of names and see who's going to be first up to play round 2. Elliot's going to keep a track of the scores as well and see who is going to win this. It looks like it's Apple Macintosh up first. So what I need, you can have as your first op, you can have a couple minutes to just have a chat about it in your Slack group, and then when you're ready, your representative should just shout out the value you want to use, which remember is the probability that your agent will on any given turn exploit, i.e. pick the best patch or what it thinks is the best patch rather than explore. Okay, so I'll give you a minute or two. If anybody's got any questions in the meantime as well, do shout those out.
Okay, I'm going with what they're saying on Slack at 0.4.
We're going to go with 0.4. Okay, so let me update the value. Find where I put it. Oh, should have remembered. Oh, here we go. Okay, exploitation rate. Ignore the default. I had to pick a random default, so it's just 0.9 by default. So we're going to go for 40%. So 40% of the time, it will choose the best patch. 60% of the time, it will just randomly pick a patch. Okay, let's try 0.4. Apple Macintosh. Let's see what happens. Okay, we're about halfway through. Okay, so we've got 49 units of treasure. So it didn't do quite as well as you did as a cohort, but still a pretty decent score. Okay, so 49. Apple Macintosh have got 49 units of treasure with a 0.4 exploration rate. Sorry, exploitation rate, I should say. Okay, let's see who's up next. Ooh, it's going to be, I think, yeah, it's going to be ZX Spectrum. So you're early this time rather than being last. So what exploitation rate do you want?
Okay, we weren't sure between a couple numbers, but I think we're going to go. Can we go 0.85?
0.85, certainly, yes. Okay, so 85% of the time it's going to pick the best thing. So you've got quite a low exploration rate. Let's see what will happen with an 85% exploitation rate. Okay, I'm seeing a nice orange on E2 there. That's a good sign. Oh, well done. 79 units of treasure. Okay, that's far exceeded what you managed as a group. So and has already smashed the previous score. So that was a good call, and we can see here that it's picked up on the two higher patches here. It still thinks that one's the best, even though that's not that great. But it has picked up that these two are quite strong, which is quite interesting. Okay, fantastic. So 79 to beat so far. Let's spin the wheel again. $79 is a solid score, actually, when you're winning at 200 turns. Okay, BBC Micro. What's going to be your exploitation rate?
We're going to go with 0.7.
0.7. Okay, so again, going with a high exploitation rate, but just maybe shaming it a little bit down a bit. Okay, let's see what happens. Ooh, it's finding some stuff on row 4. And it's gone to A5 again. Okay, 51 units treasure, so pretty decent score generally, but not quite as good as the one we had before, unfortunately. Okay, let's see who's up next. It's going to be IBM PC, I think. Yep, IBM PC. What's your exploitation rate?
We're going to go 0.7, Dan.
0.7. Okay, so it's exactly the same as you just had. Yeah.
Yep.
Yeah. Okay. Let's try it again. Obviously, there will be an element of randomness, so let's see what happens. Oh, finding a bit more in column E, which is good. 54 units of treasure. So that's Elliot, basically. That's what Elliot managed, but still not quite the heady heights of 79. So still 79 to beat. Let's see who's up next. It's gonna be Atari ST. Okay, so Atari ST, based on what you've seen, what's going to be your exploitation rate?
Can we have 0.75, please?
0.75. Okay, so trying to look for something a bit more in the middle. Let's see what happens there. Okay, seeing lots of oranges. That's a good sign. It's picking up quite a bit. Oh, I think it's found E2. It's found E2. That looks good. Let's see what happens. Oh, yeah, good score. Not quite the best, but we have found 65 units of treasure doing that. So that was a good call going up a bit. So again, very strong score and higher than we managed in the cohort game. Okay, let's look who's up next. I think it's going to be Atari 800. Yeah, Atari 800. Where do you go with this?
Can we try 0.8, please?
0.8. Okay, so that was it 0.8? No, it was 8.85, wasn't it? We had before. Okay, let's try 0.8. So we're getting closer again to the 0.85 that was so far the most successful. Let's see if this helps us at all. Again, looking promising in E2. That looks a nice strong color. Indicates it's finding stuff. Again, it's finding stuff towards the right, which is where you hope it would find things. And just to emphasize, this is a very simple agent. Oh, 88 units of treasure. Well done, you. We've got a new high score. So 88 units of treasure from Atari 800. Fantastic. Okay, spin the wheel again. That's a very strong score. Okay, it's going to be Commodore 64. Commodore 64, what are your thoughts on this?
Can we try 0.9?
0.9. Okay, so you're really going with this and thinking, well, maybe we need to exploit even further with this agent. Maybe that will help us. Let's try it. It's good logic. Oh, your landscape's looking a little bit bare. I'm not liking the look of this. That's looking very pale. Let's see what happens. Oh, it found E2 though. Oh, well, you got 79. Okay, so that was the highest score, but unfortunately it's been beaten now. But again, seems to be high exploitation rate, seems to be doing pretty well here. Okay, next up. I think it's going to be Acorn Archimedes. What are your thoughts? We've had a few values now around the top end.
We're going to go with 0.65.
Oh, interesting. Okay, so we're going to go a bit more down towards the middle. Let's see what that gives us. Remember, it'll be a little bit different every time. There's going to be an element of randomness to this. And depending on the exploitation rate, it may well, if you've got a high exploitation rate, even more of the luck is coming in because it's going with whatever it thinks is best at that time. Okay, 57 units of treasure. So again, beating what we had earlier when we played it manually, but not unfortunately the heady heights of some of the better ones. So there's a toss-up between Amiga and Amstrad. Looks like it's going to be the Amstrad Blue. Okay, Amstrad, what are you going to go for?
We've got a few options, but I think the 0.82 has the most votes.
0.82. Okay, interestingly, so we're really trying to fine tune around that sort of 0.8, 0.85 mark. Okay, let's see what happens with 0.82. It's found E2. It's found some strong ones in E. That's a good sign. It's looking pretty good. Obviously, it's going to have the same runs of good and bad luck as you did. Oh, I thought that was going to be better than it was. 56 that time. Not quite as strong. Okay, so then we're left with Amiga 500. Can you beat the highest score?
We had said 0.83, but having seen the last run, can we go 0.81?
0.81, okay.
Yeah.
Let's try it.
Thank you.
Let's see what happens at 0.81. Oh, it's found E5. Now we know E5 is the second best patch. It's got a 60% probability of yielding treasure. And because you've got a high exploitation rate, we can see it's exploiting a lot around there. And it's not exploring very much. That's looking quite promising. See what comes out. Oh, well done. Well done, 96 units of treasure. Fantastic.
Thank you.
Managed to put them on the post right at the end there. Brilliant. 96 units of treasure. Fantastic score. Okay, so that was quite interesting, observing what was happening there. How were some of the later groups? What were your sort of thoughts in choosing your exploitation rate? Actually, let me ask the first group. I can't remember who was first up. I think it was it Apple or Acorn? It's one of them.
It was Apple. I don't know what. Yeah, we just had a couple of 0.4s in the Slack channel, so that's what I went with.
Okay.
I think that first one is obviously a random, finger in the air.
Yeah. Obviously, you drew the short straw there. You didn't really know what it was going to look like. But it certainly appeared. I mean, a few groups tried slightly lower. Nobody tried lower than 0.4, interestingly. So nobody tried, well, what if we just set it to explore all the time or nearly all the time? After the sort of initial success, quite an early success of having a high exploitation rate, then that was chosen. A lot of people were sort of fine-tuning around that, and it seemed to be that a high exploitation rate for this seemed to work quite well for this particular agent and how it was working. So that leads us quite nicely on to quite an important concept within reinforcement learning, known as learning rates. So so far, our agent, whether that be us or in the case of the round we just played, the very simple agent I coded, has basically updated its estimate of each location based on its calculated success rate. So it's just said, well, I've dug 3 times here and I got treasure once, so I've got a 33% success rate. So my estimate of this patch is the payout is 33% because I dug 3 times and I got treasure once. But in a real world reinforcement learning model, you wouldn't tend to do that. You tend to use a slightly more sophisticated way of updating your estimates. And the reason you do that is because you want to be able to not only identify the level at which it should explore or exploit, but also the amount, the rate by which an agent should learn. So this basically allows us to strike a balance between the agent placing higher importance on the things that it's encountering now versus its memory of what happened before. So there's lots of different ways of doing this. One way, quite a simple way you can do this, is using something called a linear operator learning rule. In fact, this is exactly the learning rule I used for my PhD model. So here is an example of a particular very simple linear operator learning rule. Again, this is exactly the same one I used for my PhD. We were rapidly approaching the model I used in many ways, except there were travel time considerations that we don't incorporate here. We assume that any move costs a turn, but more distant moves in the B model would incur a larger penalty, and that might be important depending on what you're trying to do, and it was for that. But here's an example. So this is a linear operator learning rule, which says QI new equals beta SI plus 1 minus beta times QI old, which might seem a bit complicated, but it's actually very straightforward. So let me talk through that. So QI new, this bit here, this is the new quality or payout estimate that we are giving to an action. So in the case of our problem here, that's what's the my new estimate for the payout for choosing this particular cell. Okay, and the way I'm going to calculate that is using this equation. So QI old is whatever my previous estimate of the payout was. Okay, so if I thought it was 0.5 on the last turn, then QI old is is 0.5. SI here is the value of the latest reward sample. So in our example here, we've just got a binary reward structure. You either get 1 unit of reward or you get 0. That's it. Okay. So this SI will either be 0 or 1, depending on whether on that particular turn you dug up some treasure or you didn't dig up some treasure. In the case of my B model, it was, did I sample some nectar? Did I not sample some nectar? Then we've got beta, which is the learning rate parameter. And beta is basically determining how much that latest sample, that latest experience that you get as the agent, should influence your perception of the quality of this particular choice, this particular action, in this case, the particular cell, versus the cumulative memory that you've been accumulating over time of what happened before. Okay, so let me come back and explore that a little bit more. So if we think about this learning rate parameter beta, if beta was 1, okay, then the agent will only ever take the latest sample and it will forget everything it knew before. Okay, because this 1 minus beta, so that become 1 minus 1, this will be zeroed out. So it'll update to whatever it is. So basically the agent will just end up thinking everything is either 100% full or completely empty, because it'll just be 1s and 0s. It takes everything that it thinks about is only based on its latest sample. It's a bit like a sort of over enthusiastic child that just thinks, oh fantastic, okay, I've dug up treasure, there must be all the treasure must be here, or I found nothing, it can't have any treasure here. Okay, so it's one extreme or the other if beta was 1, and it's entirely based on what its latest experience is. Conversely, if beta was 0, then essentially it would ignore all new information. It would never update its estimates. It would only use the estimates that it had at the start. It would never update these things because this would be zeroed out, and so this would become whatever it is. So in fact, it turn all learning off. There would be no learning if beta is 0, and that makes sense because beta is our learning rate parameter. So if it thinks it's 0.6 at the start, it'll always think it's 0.6. Okay. Now, between those two extremes, as beta tends towards 1, the agent is gradually placing more importance on the latest sample and less on that cumulative memory of the payouts that it's had before. Okay, so it allows you the learning rate to adjust how sensitive it is to new experience, how quickly you want it to learn, how much stock it should place on new versus old information. So you can probably guess where this is going. So we're now going to play the treasure hunt game once more. And again, we're going to play it much like we did in the last round, where we're going to use an agent to play on your behalf, with each group competing against each other. So Amiga is currently the champions. And so you've probably worked out what you're going to need to do this time. You will once again have to give an exploitation rate, but you're also this time going to have to give a learning rate that's going to be used in the linear operator learning rule. So what will be your value of beta as well as your exploitation rate? Now, one thing to flag up here is that the agent is now updating its estimates very differently to the way it did before. So before it was saying it didn't matter if it was 0.3 that was its initial estimate of this patch. If it then went and sampled and got some found some treasure and it was its first time there, it now thinks it's a value of 1. Okay, if it then digs again, didn't find anything, it now thinks it's 0.5. Okay, that's what it was doing before, but now it's going to be using a linear operator learning rule. So it will still have a random allocation of numbers for its initial estimates, but it will then update those according to the linear operator learning rule and according to a beta value that you are going to give it. So again, we're going to randomize the order, and I will also just shut down and reopen this. Oops. Ah. So it doesn't overload. And then we will load this one up. Let me scroll down. Okay, so this time each group is going to need to give both an exploitation rate and a learning rate. But as I say, the exploitation rate that worked before may not be good here because it's doing things a bit differently. So let's reopen the wheel of names and we'll shuffle them again. Shuffle. Okay, let's spin and see who's first up this time. Okay, it's Acorn Archimedes who would have been first up anyway. So sorry about that. It is random. So Acorn Archimedes, I don't know if you need a minute or so just to just think about your answer, but I'm going to need both an exploitation rate and a learning rate from you, please.
Okay. I think we kind of have the general idea of a low exploitation rate and a learning rate. So I'm going to take an educated guess. 0.2 for the exploitation rate.
Okay.
0.6 for the learning rate.
Okay, so sort of middling learning rate and quite a low exploitation rate. So we should get a lot of exploration going on here with a slightly above average kind of learning rate. Okay, let's see what's going to happen with that kind of agent. Wow, we're getting lots of purples. Whoa, okay. Oh, that wasn't quite as good as we thought. Okay, so we've got 30 units of treasure. Not abysmal, not great, I'll be honest. So for whatever reason that didn't work so well. It was I was exploring a lot, so it was moving around a lot, even if it found it was getting quite a bit of success, and had pretty high perceptions of most things. So the next team may want to bear that in mind as we now spin the wheel again. Okay, Atari ST. Okay, so Atari ST, I need your exploitation and learning rates, please.
For the exploitation rate, could we go for 0.82, and for the learning rate, could we go for 0.6?
Okay, so keeping the 0.6 learning rate, but you're going back to the kind of winning exploitation rate from before. Okay, let's see if that helps us any. So we've got much less exploration going on this time. It's going to stick with things that it thinks are the best. It's struggling to find what the best is, but you did get a slightly better result that time. So 55 units of treasure. So still beating Elliot's score, but not quite beating what you as a cohort achieved this morning, but still the best score so far. So well done, Atari ST. 55 units of treasure, currently the score to beat. Okay, let's try the next group, which is going to be Apple Macintosh. Okay, so exploitation and learning rates, please.
Oh, we're just having discussions on the learning rate. So the exploitation rate, we're going for 0.6.
Okay, 0.6, yeah.
And I'm going to split the difference between the two on the Slack channel, and they can shoot me later, and go 0.4 on the learning.
0.4. Okay, so
yeah.
Again, it's taking some notice of the newer stuff, but giving slightly more prominence to the memory of what happened before. Let's see if that helps. And again, we've got it pretty much in the middle for exploitation, so it's pretty much flip of a coin whether it explores or exploits, but with slightly more probability it will exploit, and that got 50. So again, not a bad score, but not unfortunately the winning one so far. Okay, let's spin this again. Oh no, this will make a cracking game show. I need to pitch this to Channel 4. Atari 800. Okay, so Atari 800, you did pretty well last time. So any thoughts on your rates, please?
Oh, sorry, Dan. I think we're saying 0.4 for both.
0.4 for both. Okay.
Yeah.
So around the middle, but slightly more favouring exploration than exploitation, and slightly more favouring memory rather than new experience. Okay, let's see what that gives us. Again, we're seeing, because there's quite a lot of exploration going on, so we're seeing lots of colour. 47. So again, pretty similar, but not the highest score thus far, unfortunately. Okay, let's spin the wheel again. Can anybody get up to the heady heights we had before with this new agent? It's going to be Commodore 64, I think. Yep. So, what are your picks?
Sorry, can I ask a question?
Yeah, sure.
To see the learning rate, is a low learning rate giving more weight to what you've learnt in all of the past than what you've learnt in just the last move?
Yes, basically. So it's the value of what the latest sample says versus the accumulated memory of everything that came before.
Okay.
So low learning rate means I'm giving more stock to you're learning slower because you're saying I had a good win here, so that's nice, but I also need to remember what happened before.
Okay. Can we go for 0.8 for exploration? 8.5 actually.
For exploitation, sorry. Yep.
Yeah. And then 0.2.
Okay. So a very low learning rate. So again, not putting too much stock on what happens, just gradually trying to learn, but with a pretty much always picking the best thing, what it thinks is the best thing. Okay, let's try that, see what happens. Okay. Oh no, I haven't finished. Oh wow, well done. Okay, 77 units of treasure. That was a good strategy. Okay, so we've now got a new high score. This is looking good. 77. We're going back up to some really decent scores here. So Commodore 64 so far, the winners for this round. But we've got 5 more to go. Amstrad, it's going to be you. Can you beat the Commodore 64? No laughing, those from the 80s.
Thanks. Yeah. Can we go for 0.8 on the exploration and 0.3 on the learning?
Okay, excellent. So similar kind of strategy, just trying to fine tune that, seeing if, again, exploiting most of the time, but just gradually learning and seeing if that helps. Let's see what comes out of that. Okay, up to 34 by turn 141. 49. Not so good. Not so good, unfortunately. Not terrible though. Pretty respectable. Okay, 4 more to go. So we've got IBM PC. What values are you going to go with?
Hey Dan, so we're going to go 0.82 exploitation.
Yep.
And 0.25 for learning.
Okay, so again, a little bit of fine tuning here, but going with the same strategy that you want, not going too far in terms of the importance placed on the latest sample. I'm trying to think what the optimal learning rate was for the B model. I can't remember what it was offhand. 47. Okay, so again, not bad, but we haven't got up to those heady heights again. Let's spin the wheel again. Okay, ZX Spectrum. Any thoughts?
Can we go for 0.825 exploitation, sorry, and 0.1 learning rate?
0.1 learning rate. Yeah, we've gone to 3 decimal places now.
Yeah.
Okay. So we've got an even slower learning rate. So it's really going to be not putting too much stock on what the latest sample is versus what it had before. Let's see how that helps. And we can kind of see that in the images that are occurring. It's learning fairly slowly. Things are very gradually changing rather than the high learning rates we had before, where everything was changing very, very quickly. Here, things are just gradually being updated. Final total 60. Okay, so pretty decent score compared to most of them. Still not quite the highest score, though. Although I can't remember. Elliot, what was the highest score?
Commodore 64 was 77.
That's it, 77. Thank you. I knew it was more than that, but I couldn't remember what it was. Okay, let's. So we've got 2 more chances to beat Commodore 64 77. BBC Micro. Okay, so is it going to be you that beats them?
So we're thinking 0.85 and 0.15.
0.15. Okay, so again, just ever so slightly fine-tuning that. Let's see if that helps. Again, we're seeing that fairly slow, gradual change. Of course, that means that the initial random values that are at the start that might be decent estimates, might not be, are taking quite a while to change. So whether that's a good thing or a bad thing, I guess depends a little bit on luck. Okay, 68. That's not a bad score at all. Still not Commodore 64 though, but can its spiritual? Why am I spinning that wheel? I don't believe I've just done that. Okay, I think it's going to be Amiga 500. Okay, so Amiga 500, you won it in the last round. Can you win it again?
Last again. We thought we'd stick with our 0.81 from before.
Yep.
And we are going to go 0.1.
0.1. Okay, right. So 77 units to beat. Can we beat Commodore 64? Again, looking at the random allocation of the initial, there's not a lot. It has quite low estimates of column E, although not a bad one of E5, but we know column E is the best column. So that may not help us. Let's see what happens. 48. Oh no, it wasn't to be. Okay. Commodore 64, you won that one. So we had 2 Commodore base winners today for the group. So well done, Commodore 64. Okay. I'll get back to the slides. So hopefully that's given you a bit of a glimpse into some of the core concepts in terms of reinforcement learning. And if you were building a real reinforcement learning model, these are the kinds of concepts that you would want to consider. These kinds of things that you would want to optimize as well. So and the optimal values for some of this stuff, the learning rates and the exploitation rates, would vary depending on your problem and depending on the particular algorithms that you are using for your learning. One thing I do want to flag up though is something around what are called deep Q neural networks. Now I'm not going to go into detail about these things. If you are interested though, this is basically what the reinforcement learning session looked like in HSMA 3. It's this 2.5-hour video. Mike is very easy to watch and very enjoyable to watch. So that those 2.5 hours will fly by if you're interested in this. He's very engaging. So if you are interested, there is a great intro to this kind of stuff here, and he'll go over some of the basics of reinforcement learning, but mainly focusing on what we call deep reinforcement learning. So you can have reinforcement learning without the deep bit. So what we've talked about so far, the model that I used for my my PhD, that was an agent-based simulation where each agent was a reinforcement learning agent. You can have that kind of model, or you can use this newer style, which is using what we call deep Q neural networks. So remember, deep learning, anything deep in machine learning world means neural networks. Okay, our old friends, neural networks. And basically, deep Q neural networks combine the principles of reinforcement learning that we've talked about with principles of neural networks. And they use something called Q. And Q is basically, it's a way of quantifying the expected maximum long-term reward for a particular action from a given state. So to put that a little bit more simply, it's a bit like it gradually learns to be able to take decisions that might appear not to be great initially, but in the long term could lead to a bigger payout. So by taking this decision, it looks like things are going to go wrong for a bit, but actually this is a much more sensible approach. And Q allows you to quantify that in some way. Okay, and the way Mike will explain it in the video, the way it does this is essentially by using the branches of a neural network to say, what if I took this decision, and then this thing happened, and then that thing happened, and then that thing happened. And Q quantifies that sequence of events, giving potentially a diminishing importance to things that are happening further away. So something that happens now or tomorrow is likely to be more important than something that happens a month down the line, or 6 months down the line, or a year down the line. But we may still want to consider that more sort of long-term vision, and Q allows us to do all that kind of stuff. Now, as I say, we don't now at the moment cover this in HSMA because it is quite complicated. But I would encourage you, if you are interested in this, do check out that video from Mike. All of these slides will go up on GitHub, by the way, and I'll link to that so you can watch that video. It's on our YouTube channel, but it's in the HSMA 3 playlist, and it's a really good intro to this kind of thing. If you're interested in getting into some of the deeper stuff around reinforcement learning. Okay. What we're going to do now is we are going to take a short 5-minute break. Then you're going to go into your groups, and you're basically going to come up with some ideas about how reinforcement learning approaches could be used for problems in your own organization. So we've talked about Annika Rice flying in a helicopter and digging up treasure, but actually other ways in which this kind of stuff can be really useful for some of the problems that you have. Now, what I'd hope to do, although we've slightly run over, so we'll do this a little bit differently. There are a couple of very short videos here. One's 6 minutes, one is 9 minutes. Again, from my colleague Mike, who's done some exploratory work around using reinforcement learning for healthcare-based problems. One is called The Learning Hospital, which is combining deep reinforcement learning with hospital simulation. So, in other words, combining this kind of stuff with the discrete event simulation we covered, the SimPy kind of stuff, and can we get those two things working together? And then this video, which uses deep reinforcement learning agents to work out how to dispatch ambulances. Okay, these are both exploratory projects. Okay, these aren't kind of, they are real world, but they're not, they're more exploratory proof of concept kind of stuff. But this will give you a bit of an indication about the sort of things that you can feasibly do with reinforcement learning. Now, I'm conscious of the time, and I want to give you ample opportunity to have a chat in your groups. So what I suggest, take a 5-minute break to about 22 or just after. Then I was going to get you to watch both videos. I would suggest that maybe perhaps sort out half of you watch one of the videos, half of you watch the other. So allow 10 minutes for that. And then basically have a chat until about 25 past 4, and then we'll bring everyone back to share any thoughts. So go and have a 5-minute break, go and watch one of these videos. You might want to chat in your groups about who, make sure that everybody in the group has watched both, you've all as a group watched both of them, and then come together and have a chat about potential ideas for how this stuff could be used. But do have a look at one of these videos, and obviously afterwards, after the session, watch the other one that you didn't get a chance to watch too, because they're quite interesting potential uses of this stuff. Okay, I will stop sharing. I will open up the breakout rooms now, but go and stretch your legs for 5 minutes first, and I'll float around once you're in your groups. Hi everyone. Okay, welcome back. So I managed to get around to a few of the groups and had some really interesting discussions around some of this stuff and how it could be used. So I thought it would be worth just coming back a few minutes before the end just to share some of that, because I think people are picking up there's some interesting ways in which this approach can be used, particularly for thinking of it as a sort of way of optimizing existing models. So does anyone want to sort of volunteer anything they were talking about in their groups? Any ideas you had for some of this stuff? Yeah, Jason.
Hi, so just one off ours. So we talked about to kind of using this reinforcement to allocate tasks to the tasks in a clinical setting, and there are different types of tasks with different types of rewards. So there are tasks that benefit patients, so kind of time to treatments, so time to get antibiotics, time to have your wound reviewed, these kind of things, and those benefit patients through better outcomes, so you can reward that. But then there are actions that kind of benefit the environment, so the hospital, so getting patients discharged, which might mean removing cannulas and dispensing discharge medications, would mean that the patients could leave the department, and then kind of the next patient could be managed. We had thoughts around kind of time to treatment, not time to treatment, but the RRT targets, and optimizing clinic lists to reduce breaches of the target, and using a model that kind of benefits that. One of our team works with the police and was interested in thinking about rewarding a model that maximized the probability of responding to events, while also simultaneously minimizing the resource needed. And we had a final one which was around call handling, and we kind of thought about major incidents where maybe you could triangulate call origins, and the model could think about diverting calls to external service providers to be kind of triaged, and focusing the local command and control on the calls that were just within the hot zone or within the main incident area. And kind of it's something you could just switch on, and it would just take all the thinking away from you. And that's it.
Yeah, no, definitely. There's some really good ideas there, and as I say, that it's really getting to the heart of that. Sort of what are the thinking about a reinforcement learning agent? It's almost like a kind of an additional AI-based sort of decision maker that you can have there that will kind of support. Well, I think looking at this, I think we should try this. And thinking about what your rewards are, what are the what are the good outcomes, and how does that get rewarded, and what are the actions that the agent can take in terms of decisions that it can put forward. I think with any of these things, it's easy to go down the sort of ethically problematic route of the AI kind of taking over the decision. So it's very important, I think, to remember that they are, particularly when you're building something like that, which is almost like a decision maker in itself, that even so that would be a decision support mechanism. So you can imagine, in the hospital, so those who watched the video on Mike's hospital bed capacity thing, that's a really good example. So you can imagine having an agent where it's working with the SimPy model and saying, okay, I've tried removing 5 beds, and that seems to work quite nicely, and I think you should do this. I can see something coming. I can see I think there's going to be a breach I think we're about to see something catastrophic happen in the hospital. I think we need to do this. But of course, that agent should then be presenting that information to the decision maker, saying, "I think this is what's going to happen, and I think this is what we're going to need to do to solve it." And then sort of putting it over to the decision maker then to make that choice. And the output of what actually happened could then be fed back in to the agent to say, well, we did this and this happened, and sort of going through that cycle. Really interesting. Anybody else have any other sort of ideas they discussed?
Hi. So one thing we talked about, my project is going to be about, I'm an anaesthetist, and it's going to be about modeling the process of patients getting referred for surgery, and they might need to be seen in a clinic, or we'll have a scan, or have an anesthetic assessment, and all of that is, different resources. Essentially, you can model them in SimPy, and I was thinking that would just allow you to see the bottlenecks in that process. But then, having just seen Mike's video there, the Learning Hospital thing, I'm now wondering if you could then, having built that model, apply some sort of deep learning to it and see if you could optimize the amount of clinics of different types that you have on in any particular week. So that was very interesting, I thought, from what I was planning to do.
Yeah, definitely. I mean, that sounds very similar to what Mike's kind of looked at, and it's I definitely think that's something that you could explore. So to be totally frank, this isn't easy, this stuff. Working out this is kind of uncharted territory. I mean, reinforcement learning's been around for a long time. Deep reinforcement learning, whilst newer, is still fairly well established, but the kind of combination between that and sort of the hybrid modeling approach of using that with a discrete event simulation, for example, is novel. I mean, so much so we had he had to drop out, unfortunately, but we had a PhD student whose entire PhD was going to be looking at exactly that. How do we do this? How does that work? What does it mean for a SimPy model to reward an agent that's monitoring that? So it's not easy, and it requires, but I think it could be interesting. And so it's something that you could potentially sort of play around with. I think that could be quite an interesting avenue to go down. I think perhaps not as the sort of primary focus, but definitely as you say, sort of an add-on to your existing model anyway, to expand on that. I think that could be a really interesting thing. Certainly if you're interested in that, I'm sure Mike would be very happy to sort of chat through ideas on that kind of stuff, because he's very much been sort of playing around with that on and off over the years. So yeah, definitely. Brilliant, thank you. Okay, we'll stop there because we've slightly overrun. Fantastic. Well, I hope you enjoyed our new session this afternoon, and hopefully it was a sufficiently light session after the Python assessment this morning. But hopefully it's given you some thinking about how something that's a bit more kind of cutting edge and a bit more exploratory can actually be used to enhance some of these existing methods that we've looked at. So you have now seen basically all of the methods that we're going to show you. The only two things we've got left to teach you in the program are, or in the phase one of the program, is the R, which is a kind of a little side thing for those of you who want to learn a bit of R, and Git, which is a complete pain in the bottom, but is quite important. And if nothing else, the very first hour of that session, where we talk about why we do open science and why we are teaching you a course where you don't pay for a single piece of software, and why we encourage you to put everything on GitHub and share it, and why that's so fundamentally important for what you're doing, it is very important too. But you have now been exposed to all of the methods, and so should now have enough information to be able to put together your project pitches. So you've got 4 weeks from today to get those project pitches in. 28th of March is the deadline for that. Do make sure you read back through the instructions very carefully, and remember to focus on the things that we've told you to focus on. Fundamentally, the most important thing we need to know is why we should care about what it is that you're doing, because impact is by far the most important criterion that we're judging it on. We obviously won't be able to take forward all of the projects, and it's important to say now that we, judging on, was it 41, I think, that took the assessment this morning, and there's a few others take it. So, I mean, we're likely looking at about half, maybe, that we'll be able to take forward. So not everyone's going to be able to take a project forward in the program, but obviously we will take forward as much as we can. And that shouldn't discourage you from being able to, still work on this stuff yourself. It's just what we can formally mentor. But we will do our best to take as much as we can. So just a reminder, next week will be the R training from Simon, the first one. You'll then have a week off. That would probably be a good opportunity to start getting your pitch together in earnest, if you haven't already, and use that data to get stuff together. Then there'll be the follow-on Simon session, and then the very final on the 28th of March. That is the deadline for the project pitches, and also the day of Git, where we will look at free and open source, what that means, and what it means to enter the nightmarish world of using Git and GitHub in earnest, and hopefully that will be enlightening, if nothing else. So hopefully you've enjoyed an exposure to the various methods that we've shown you, and do keep posting on the Slack forum about ideas you've got. If you want any feedback, now is the time to be talking to people about potential collaborative pitches as well, if you want to put things in together. Collaborative pitches are a good thing. If you're looking at similar stuff, it might be worth putting in a collaborative proposal. That's a big tick from our perspective. Collaboration is one of the things we like to encourage within the program, and we had a number of collaborative proposals last year as well. So that's never a bad thing to do. Other than that, I think that's everything covered. So yeah, enjoy our. I'm gonna have to. I've just remembered I'm hosting the session, so I will be here for R in body, if not in spirit. But don't ask me for any help. The last time I tried to help in an R session, I confused everyone and then just quietly walked off. Simon is an excellent teacher and will be able to help you. But don't ask me. I will just sit there and nod and make the occasional joke. And that'll be me. So yeah, our next week, I will get the recording up for this over the next couple of days. Obviously, there's no solutions to upload us. I've put up everything on GitHub now, so you've got access to that, and hopefully it's given you lots of thinking to do. So good luck everyone with your pitches. If you've got any questions, obviously do let us know. And hopefully you found the assessment okay this morning. And as I do, look out for the surveys, which we'll post around the end of March. Please do fill those in, because that will help us to work out how to evolve things in the future. Hopefully, if nothing else, we have demonstrated we are responsive to feedback, particularly when we Elliot really put together that fantastic recap and revision sessions at the start of the course. So we do respond to what you advise, and hopefully we can evolve it. And do stay tuned for the thing that I told you about that I can't say because I'm still being recorded. But there will be information incoming, but rest assured, we've got it. It's been agreed. So hopefully it might be next month that we'll be able to especially if it's complimentary. Yes, I did suggest to Elliot that the scales should go from 9 to 10 rather than from 1 to 10, but we felt that was a little, particularly the questions about how did you find the trainers, but we felt that might be a little biased, but please be honest, and complimentary at the same time. Excellent. Okay, I'll stop waffling and have a good break, and see you next week for pirate themed antics in the world of R. Okay, see you everyone. Bye bye.
Thank you, Dan.